One, Mr. Henninger's back. Uh, Good to be with you all again, one way or another. And this week we're going to look at something called the triangle inequality theorem. Now I know Ms. Z already posted a PowerPoint video on this on Teams, but I'd also like to post another video on this just to give you guys a little bit of extra information here. But before we begin, it's been a little while, so I missed a couple of things. Number one, happy belated birthday to Killen. Your birthday was on the 1st. Didn't forget about you. Belated birthdays also to Justin File and Giuseppe on the 3rd. Hope you guys had a really great birthday and managed to do something nice. Uh, Hopefully it was a good one for you guys. Now, let's get to work. So the triangle inequality theorem. So as you saw on that PowerPoint, triangle inequality theorem states that the sum of the lengths of any two sides of any triangle is greater than the length of the third side. So if we have side lengths A, B, and C, A plus B has to be greater than C. Now, from this, we can actually get a second kind of mini theorem that rolls off of this one. They call this a corollary. What the corollary states is that the difference of the lengths of any two sides of a triangle is less than the length of the third side. So if we do this with the A, B, and C again, what this looks like is A minus B has to be less than C. Okay, so if we add the two sides together, that has to be greater than the third side. And if we subtract two sides, that has to be smaller than the third side. So there's a couple of different things that we can do with this. Okay, one thing that we can do is if we have two lengths of two sides of the triangle, we can find a range of possible lengths for that third side. Now, it's an important note here, guys. We're talking about a range of possible lengths. We're not finding the exact value for that third side. We would need more information to do that. But we can find a range of possible values. So we know it has to be at least this big and no more than this big. So let's take a look at this. Okay, I have sides 5 meters and 7 meters. Now I know this third side. I don't know what it's going to be exactly, so let's just call it x. Okay, that's an unknown value for this. But I know that if I take these two sides, 5 meters and 7 meters, and I add them together, so let's do 7 plus 5. I know that has to be greater than that other side, x. And we also know that if I take those two sides and I subtract them, so 7 minus 5, I know that that has to be less than that third side, x. So we simplify both sides that we can. 7 minus 5 is 2. It looks like it says negative 2. Oop. Hold on, guys. There we go. Okay, so we subtract those two, we get 2. Okay, that has to be less than x, which has to be less than 7 plus 5, which is 12. Now, one little detail here that's really important, guys. Don't forget units, because there's a big difference between meters and feet and inches and miles, and we want to make sure we use the right units at the right time. So that third side, x, has to be between 2 meters and 12 meters. Now, it's important to note it's not less than or equal to. Okay, it's just less than on both of those. So it can't be 2 and it can't be 12. It has to be somewhere between those values. Okay, let's take a look at number 2. Now, number 2, same kind of idea. They give us two side lengths. This time it's a slightly bigger triangle. But we're going to do the same thing. We're going to take those two sides that we're given, 40 inches and 30 inches, and we're going to subtract them. Okay, and that third side, let's call it y this time. That sum has to be less than y. Okay, now if I take those two sides and we add them, that has to be greater than that third side y. So we simplify the two sides that we can. Okay, 40 minus 30 is 10. Has to be less than y. Has to be less than 40 plus 30, which is 70. Okay, and this time it's inches. Okay, so that third side y has to be between 10 inches and 70 inches. And once again, it's not or equal to, it's just less than symbols. So if it's exactly 10 or exactly 70, that triangle can't happen. Now we've got a third one over here. I'll leave that one to you to practice if you want to. Your answer that you should get, that third side, let's call it z this time, would have to be greater than 1.7, and it would have to be less than 21.3. Now, if you want to practice that one on your own, go right ahead and save that one for later. All right, so if we want to find out what the range of possible values is for the third side, we subtract the two sides that we're given, and we add the two sides that we're given, and that third side has to be between those two values. Okay. All right, now, one of the other things that we can do is if we're given three sides, we can determine whether or not that makes a triangle. So they want to know, is it possible for a triangle to have sides with these given lengths? So here's the problem. The triangle inequality theorem states that the sum of the lengths of any two sides of the triangle is greater than the length of the third side. So what that means is we would have to try all three pairs. So I would have to do 7 and 3. I'd have to do 3 and 6. I'd have to do 6 and 7. And that's a whole lot of extra work that we really don't want to do. So what I always like to do is try to find a shortcut that I can give you guys that'll work every single time. And here it is. Take the two shorter sides. Okay, so the two shortest sides in this example are 3 feet and 6 feet. So we add those two together. So 3 plus 6. And we're going to compare that to that third side 7. Well, 3 plus 6 gives us 9, and 9 is greater than 7. So that triangle inequality theorem states the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Well, 9 is greater than 7. That checks out. So we can say that on this one, these sides, these lengths, can form a triangle. And there we go. All right, now let's take a look over here. We've got 13 inches, 28 inches, and 15 inches. So we're going to take the two smallest sides, which are 13 inches and 15 inches, and we'll add those together. 13 plus 15. And we'll compare that sum to that third side, which is 28. Well, 13 plus 15 is exactly 28. And 28 equals 28. So we got to think a little bit on this one. Okay, we have to be really careful. Now, the good news is the words that they use in math are extremely specific. And the words that they use for this triangle inequality theorem is that the sum of the lengths of any two sides of a triangle is greater than the length of that third side. Well, 28 equals 28. It's not greater than. So this one can't work. So we'll say very clearly, these sides or these lengths cannot form a triangle. And there we go. There's our answer. Ooh. There we go. These three sides cannot form a triangle. So if we have three sides and we want to determine whether or not it can form a triangle, we take the smallest two sides and we add them together. If that sum is greater than that third side, you got yourself a triangle. If that sum is not greater than that third side, so equal to or less than, those sides cannot form a triangle. If we have two sides and we want to find a range of possible values from the third side, we take those two sides and we add them together and we subtract them. And that third side has to be between the difference in sum of those two given sides. Okay, and there we go. All right, guys, there's also a worksheet posted onto Teams, a separate assignment. There's an answer key for the odd numbers, so you can check your work on those, and we will check your work on the even numbers. There's also going to be a little quiz on Friday, real short quiz. I think it's 5 or 6 questions. So make sure that you log on Friday and get that taken care of. It won't post till Friday, so make sure that you have some time set aside to work on that. All right, guys, if you have any questions, hit me with the email or Mrs. C with the email, and we will talk to you then. Take care.